All right, section 1.8, day one. Today we'll be working on adding, subtracting, multiplying, and dividing functions. Something you've seen in the past, but you have not seen compositions in Algebra 2. So we can find the composition of one function with another function. Those two learning targets will be our main focus today. Okay. All right, so you see some rules down here in this box for the sum function. When it's denoted this way, f plus g in parentheses with x next to it, they basically are asking us just to add the two functions together. Same thing with difference. All right, when two things are next to each other in math, we know it means product or multiply. So we're going to multiply these together. And the quotient's actually the easiest of the four because we usually can't simplify them in this section. Okay. All right, so let's take a look at the directions for this first set of problems. Given this f of x and g of x function rules, evaluate the following functions. So f plus g using 3. I highly recommend we just ignore the 3 for now. Let's go find the sum function of f plus g first. Okay, so just like this, f plus g of x just means, like it says up here, right? I add f of x plus g of x together. So f of x is 3x plus 4, and g of x is x squared minus 4. And then I just combine like terms. All right, there's nothing outside the parentheses to distribute except for positive ones, and we typically put this in order of highest degree. So x squared goes first. 3x can't be combined with anything either, but the 4's can. So a 4, take away 4 gives me 0. So that is our sum function. Okay. All right, now that we have the sum function, no matter what input value they give us, now we know just to plug in that for x. So 3 is going to go in here. So f plus g evaluated with 3 is 3 squared plus 3 times 3. So it gives us 9 plus 9. We get 18 for the answer. Okay. Okay, so for 2, they give us a difference function. They put an input value, but we're better off sticking with finding f minus g of x first. So I recommend using parentheses too whenever you get this set up, especially with the difference one. A lot of students will make the mistake right here on this next step. Okay, you have a minus sign outside of parentheses. That means we have to subtract everything in the parentheses. Or some students like to take care of it this way. You can put a -1 coefficient in front and distribute that to make sure you change the signs. So there's nothing to change on the first quantity. You could distribute a positive 1 if you want to stay consistent with that. So 3x plus 4, this becomes a minus x squared and a positive 4. Okay, and now just collect like terms and we'll have our difference function. All right, so now we have our difference function. So f minus g using -2 now. Careful with our negatives here. Negative out front, so I'm just going to put -1, now parentheses x, so now I plug in -2 inside, like that. Okay. Now, if you're worried about messing up the order of operations or making a small mistake with some mental math, the safe approach is to plug it in here, but we would have to, if we did it step by step, do your exponents to get positive 4, then multiply, and then add. But here we can punch it in just like this. -2 squared plus 3 times -2 plus the 8. Carbon copy of what you see on paper, and we get -2. Okay? So that's our answer. Okay, 3, I'm going to try to get you a little more involved. I'm doing all the work right now. Moving on to products. Let's ignore the -1 for a moment. Let's find f, basically f of x, right, times g of x is what we want to do first. That's what the product function says to do, right? F g of x means f of x times g of x. Okay, so whether you are using the distributive property to do this or using FOIL, I'm going to pause here and give you a moment to go ahead and FOIL this and get your product answer. Okay, go ahead. Okay, so one step at a time. First times first. Okay, we get 3x cubed. Outside two terms, -12x. Inside two terms, we get 4 times x squared. And the last two terms, 4 times -4. Okay, maybe just rearrange it to put it in order. And then we're ready to plug in -1. Okay, so we didn't punch this in the calculator yet. I got it for you. It's -3. Okay, moving on to the quotient function. So f over g of x means we just take, right, f of x and divide it by g of x. So f of x is 3x plus 4. Divide that by x squared minus 4. Now, when we get into what's called rational functions, because this is a rational function, but we have some sections dedicated to rational functions, and we'll be able to simplify some of these, like factor this and see if something will reduce. Most of them in this section aren't reducible, okay? And you can't do anything with it. So that's it. Most of the time for these problems, you put f over g, and that's the answer to the first part. Okay, we didn't quite finish this. We got to plug in 3, but we're done for that quotient function. So f over g now using 3. Just try not to do too much at once when you're evaluating this. Just focus on the numerator, then the denominator separately, and then we'll divide. So I get 9 plus 4, 13 up here. And here I get 9 minus 4, so we get 5. So that is reduced. That might be the way they write it in the back, or if you change it to a mixed number, 2 3/5. Okay, that's the quotient function. Okay, so 5 and 6 are very similar. So let's, for sake of time right now, let's jump to 6. I'm going to set it up for you and let you try it. Try to finish it. All right, now this was going back to the sum function. We already have the sum function from problem 1. F plus g of x is already done. It's x squared plus 3x. So let's write that down. F plus g of x is equal to x squared plus 3x. All right, I'll just put a reminder here from problem 1, from number 1. Okay, the only difference here, instead of plugging in a number like number 1 did, it said to go ahead and plug in 3. Now we're going to plug in an expression instead of 3. That's all. So instead of 3 there, we're going to see t plus 2. Okay, so the sum function evaluated with t plus 2 is, right, plug it in right here, t plus 2 quantity squared plus 3 times t plus 2. Okay, try to get about 30 seconds ahead of me now. Let's see if you can expand this correctly. All right, expand t plus 2, FOIL it, and then multiply it by 3 and get your answer. Go ahead. Okay, here's the solution to 6. So when you expand t plus 2, this is what we get, t squared plus 4t plus 4. Okay, and then we got the 3 times t plus 2. Combined like terms, we get t squared plus 7t plus 10. Okay. All right, moving on to the next page. Now 7 and 8 and 9 are all a lot like the previous page, except now they aren't asking us to plug in a number. So it's actually a little bit shorter of a process. So f plus g of x, I'm going to add these two together. Then you do the difference, then you do the product, and then you do the quotient again. All right, so I'll pause here for a moment and let you guys try these, and I'll give you feedback. And then when we're done too, we'll also identify the domain of these resulting functions. All right, so go ahead and try A through D. All right, here's the sum function. Combine like terms, x squared plus x minus 6. B, did you remember to change both of these signs, negative x squared and a positive 9? If you did, you probably got the right answer then. Negative x squared plus x plus 12. Okay, and C, the product function. Here's F, O, I, and L. This is too fast for you home. Pause it. Take a look at it. And then usually rearrange it. So here's the final answer. Okay. Now all three of these, there's no problems with these functions, meaning we can plug in any number into these functions and get a real number as a result. So the domain is all real numbers. Okay. Domain is negative infinity to positive infinity for A through C. Okay. It's when we have expressions in the denominator, that's an issue. It's when we have expressions under an even radical, that's an issue. So that's going to happen in D. D will almost be all real numbers, but we'll have a couple restrictions. Okay, so for D, x plus 3 over x squared minus 9. Well, actually, we could simplify this one, but like I said in this section, let's not worry about it. This is all I expect you to do. But now, we might get 0 in the bottom. And so we can just look at it and realize, okay, 9 minus 9 is 0, so that means 3 and negative 3 don't work. The algebra step, if you don't see it, is to take the expression, set it equal to 0 off to the side, and solve to figure out what gives us 0. So I factored it using a difference of 2 squares, or you could use the square root method. Add 9 and take the square root. So we get negative 3 and 3. Those are going to be restrictions on the domain. Now, if you're writing this on your own, yes, it's easier to write it like this, but in the back of the book and on your multiple choice, they're going to write it using interval notation. So let's take a good look at this. How do we write these exclusions using interval notation? Remember, the big picture is, if I cover all this up, negative infinity to positive infinity is the domain. So how do we get rid of these numbers? Here's the solution. So we say negative infinity to negative 3, parentheses means we don't include that. And we go in order from left to right on the number line, right? Because basically we're doing this on the number line. Negative 3 is here. Solutions are here. Open circle to 3. Open circle going this way. Okay? So negative infinity up to negative 3, parentheses, the union of negative 3 to positive 3. And then we pick back up at 3 and go to infinity. Okay? Give me a moment to write that down. Okay, let's wait on 8 and 9. I want to introduce composites today as well. So let's get to this new topic on the next page. All right, the definition is key for the order of your substitution. Okay, so when you see this little open circle, we actually use the word composed. This reads F composed with G. And whatever's closest to X goes kind of inside the function or inside the belly of the other function. Okay. We're not going to work too much on domains of these ones, just mainly on creating these compositions. All right, so let's take a look at the directions down here. Given these functions, f and g, find these compositions. Let's go ahead and label it A, B, and C for our work, okay? This is part A, part B, and part C. All right, so the first thing we should do for part A is make sure we follow the definition. Okay, F composed of G with X. Since G is closest to X, we should rewrite it with G of X in the middle. That gives us a direction for the substitution.